Welcome to The Explainer. Today, we're diving into a part of JavaScript that can make your code act in ways you would just never expect. We're talking about comparisons and how a feature that seems helpful on the surface can actually become a hidden source of some really frustrating bugs.
Okay, let's jump right into this. We all know that the number 2 is greater than the number 1. Simple enough, right? But what happens when you're comparing a string, 2, to a number? Well, as we're about to see, JavaScript has some very specific and honestly sometimes very strange rules for this exact situation.
First, let's cover the basics, the predictable stuff. These are the comparisons that work exactly like you'd hope they would, and they form the solid ground of our code's logic.
When you're comparing apples to apples, numbers to numbers or strings to strings, JavaScript's behavior is totally straightforward. This is the foundation of how we make decisions in our code, and it's simple, clear, and it just works.
But the real confusion, and where those subtle, tricky bugs start to creep in, is when JavaScript has to compare values of different types. This is where the simple rules suddenly get a whole lot more complicated.
So what's really going on behind the scenes? Let's take a look at the hidden mechanism that causes all this strange behavior: automatic type conversion.
Pretty surprising, right? JavaScript says both of these comparisons are true. It's looking at a string and a number, and yet it's able to come to a decision. So how on earth does it do that?
The reason is a feature called type coercion. You can almost think of it like a helpful but sometimes really clumsy friend. It sees you're comparing two different things, so it tries to help by making it guess and just silently converting one to match the other.
And this slide breaks it down perfectly. First, JavaScript spots that you're comparing a string and a number. Then it just automatically converts that string into a number. And only then does it actually compare the two numbers, which is why we end up getting a true result.
Now, while this automatic conversion can seem useful, it is a massive double-edged sword. As the source material warns us, this helpful behavior can lead to totally unpredictable results and create these subtle, hard-to-find bugs hiding in your code.
Okay, and this is where things get really weird. Let's take a look at how JavaScript handles comparisons with the special values null and undefined. If you thought that string conversion was a bit odd, get ready for some truly mind-bending results. When it comes to the value null, JavaScript's rules can seem to completely defy all logic.
Just look at this. Null is not greater than 0. And it's not equal to 0. So logically, it shouldn't be greater than or equal to 0, right? Wrong. That comparison returns true. This happens because the rules for how null gets converted are completely inconsistent across different operators. So the key takeaway here, the really crucial point, is that JavaScript's relational comparison operators, like greater than, have different conversion rules than its equality operator, the double equals. This inconsistency is a huge source of confusion and a really common cause of bugs.
And what about undefined? Well, at least it's consistently uncooperative. When you try to compare undefined to a number using any of these operators, the result is always going to be false. It just refuses to be converted for these kinds of comparisons.
So after all this weirdness, how do we write code that's actually safe and predictable? How do we avoid falling into these traps? Thankfully, there is a simple and really effective solution.
And the answer is the strict equality operator, or the triple equals. This is your absolute best defense against that unwanted type coercion. It checks if two values are equal in both their value and their data type, with absolutely no secret conversions allowed.
Here's a side-by-side that makes it all crystal clear. Loose equality, the double equals, will do that sneaky conversion and tell you that the string 24 is equal to the number 24. But strict equality, the triple equals, correctly tells you they are not, because, well, they're different types. It's predictable, and that's exactly what we want in our code.
So, what's the big takeaway here? Well, avoid comparing different types whenever you can. Be extremely careful with null. And most importantly, make the triple equals your default for all equality checks. This one simple habit will make your code so much more robust and way easier to understand.
We've just seen how a really small change, like just preferring triple equals, can save you from a world of hurt. It's a great reminder that sometimes the most powerful tools are actually the simplest ones. It makes you wonder, what other simple rules do you rely on to write great code? That's a question worth thinking about.